after the Hadean, which was Earth's first eon. After the Archean, which was Earth's second eon, we get to Earth's third eon, which is the Proterozoic, right? Shown here. So we finally are moving into the second half of Earth's lifetime. Now, because Proterozoic rocks are generally less altered than Archean rocks, they're younger, they haven't gone through as many rock cycles as earlier rocks, they're easier to interpret. Right? However, there are still some difficulties. This is because Proterozoic rocks typically lack abundant fossils. Right? There wasn't very much life around at this time, so there weren't very many fossils preserved in them. Even though there was material preserved, it's harder for us to interpret. Now, notice that the Proterozoic is split up into three different eras: the PaleoProterozoic, the Mesoproterozoic, and the Neoproterozoic. We are going to go through all of those, starting with the PaleoProterozoic. This was about 2.5 to 1.6 billion years ago. Okay. Now, the PaleoProterozoic was eventful. It wasn't maybe eventful for life, but it was eventful for Earth. By this time, plate tectonics were in vigorous operation. There was major mountain building on all of the continents, and Earth experienced its first great ice age. Okay. So lots of things happening on Earth at this point. As I said, tectonics were in full swing. So during the PaleoProterozoic, before there were any supercontinents, mountains were still forming. There still were orogenic events creating these mountain belts. Right? So we do see some evidence of mountains still around today, such as in northern Canada, we find evidence of mountains that were created during the PaleoProterozoic, okay, billions of years ago. Not only were there mountains forming at this time, this was also Earth's first ice age. Now you might ask yourself, again, how do we know? If this happened so long ago, how do we know that this was Earth's first ice age? Well, we know because of the sediment deposits left behind, right? Sedimentary rocks can preserve so many events, so many processes. So we know there was an ice age because of the sedimentary rocks preserved. Now, when glaciers form, they go through periods of building during the winter and then melting back during the summer, and then building during the winter and melting back during the summer, which means there's these periods of melt every year where lots of water is flowing off of the glacier. And because we go through this yearly cycle of meltwater pulses and then nothing, and then meltwater pulses and then nothing, the sediment that is created at the bottom of a glacier because of that meltwater coming out also creates layers, right? Where when glaciers advance, they erode and transport coarse sediment, in this image shown by the lighter color material. And then when they melt and wash out a lot of that sediment, fine mud deposits in the calm meltwater seasons form. So we get layers of larger material, finer material, light material, dark material. We call these layers varbs. So with these varbs, we can actually see that there was evidence of glaciers about 2.3 billion years ago, which is called the Earth's first ice age. Now, around this time, we also had banded iron formations, right? They were created before this time, but this is when they became really extensive. Again, iron is formed when we know there's oxygen in the atmosphere. And it's a good thing it formed early on because iron is the backbone of modern civilization, right? We use iron to create our industrial materials, our tools, our buildings. Right? And a lot of the iron that we use today, the iron that's in the building around me, a lot of it comes from the PaleoProterozoic banded iron formations. Many of these formations were deposited 2.6 to 1.8 billion years ago. So the building I'm standing in has material that was formed 2.6 to 1.8 billion years ago inside of it, probably. Right? And the banded iron formations occur in these huge bodies that can exceed hundreds of meters thick, thousands of meters wide, which makes them really great areas for us to mine the iron.